everyone, and welcome. Thank you all for joining us today for this live stream event. My name is Rebecca, and I'm the event planner of the Microsoft Reactor New York. Before we begin, I'd like to quickly review two items, our code of conduct and event guidelines. So our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but we just ask that you're mindful and your comments remain on topic and professional. So today's session is being streamed live to you through YouTube. If you are new to the Reactor programming, if this is your first time on YouTube, you will have to create an account on YouTube to interact in the chat. If you don't want to do that, and you've joined us through somewhere like meetup.com, you can always send one of the Reactor coordinators or organizers questions there, and we can respond to you at a later date. But yeah, while we're on this session, if you have questions, comments, feedback, let us know in the chat. This video is recorded. It will be available on demand on the Microsoft Reactor YouTube channel. Probably in the next 48 hours or so. I've shared in the chat with you links to the specific YouTube series page for Alfredo. We've done one session already, so that's up there. I've shared with you our series event calendar in the chat, and also the check-in link for today's session, which brings us to today. So we want to welcome back all of you, if you came in for the first one and now you're joining us for the second one of this 5-part Python series. We're joined once again by Alfredo Deza. I'll bring us up here on the screen if you want to hang on 1 second. And hey, Alfredo, so you can just unmute yourself whenever you're ready. And Alfredo is joining us. He's a cloud advocate here at Microsoft. He's put this wonderful series together, and we're happy to have him again for part 2. Yeah, and today we're going to be running through conditionals. So he'll walk you through all of that, how that works. Last week, we did kind of an intro to setting yourself up. So if you missed that, again, we shared the link to the recording in the chat. Do, when you have some time, check that out, just so you're all caught up and familiar if you're new to Python. If you have not checked in already, we do recommend that. The event resources are there. So the Learn module we're covering today, which is free, so just go and sign up there and get that. Some lead-up information about setting yourself up for Python, and just additional information about both Alfredo and this series. So I will step away now and give Alfredo the floor. Okay, thank you so much, everyone, and thank you, Alfredo, for joining.
All right, well, thank you so much, Rebecca. And just a very quick sound check. Last time we had some microphone and input-output problems. If you can hear me fine, then that's great. We can get started with conditionals and variables. So what's the deal with conditionals and variables? Great to hear that you guys are hearing me. Perfect. That's awesome. So what's the deal with conditional and variables? In the first video of this series, we went through using VS Code, installing a text editor, installing Python, everything that you need to start being proficient in Python itself. But now that you have all of that set up, like you're ready to go, you're ready to start writing some good Python, then the next step, of course, is to, well, like I think the very first step is, well, write some code. But writing code, it naturally has to go into conditionals. Like you get faced into this, you get thrown into these situations where you're like, well, what am I going to do this? What happens if that value is one thing and not the thing that I want? Should I take this action over here or that action over there? And that's where things start getting interesting, because now you can allow the code itself to make these decisions. And I tend to think about code and programming itself as recipes. And sometimes, at least when I got started writing Python many years ago, I don't come from a traditional computer science background. I didn't learn to program in college, and I was uh, kind of like self-taught. Like I had to read a bunch of books. And what happened to me was like I was writing code that was like very much like a recipe, like very from the top. It sometimes is referred to like as top to bottom or top bottom code, procedural code. One step, then the next step, then the next step. No functions, no classes, no nothing, just very simple. But even if you start writing or programming that way, you're gonna get into a certain uh, a portion in time or piece of code that you're gonna be like, I need to make a decision. What do I do here? In a recipe, that could be like, hey, if do all of these steps, you're gonna create a sauce. Do all these steps. If the sauce is still a little bit thick, you can add a little bit more water. Make sure that the water is heated up. So you're getting into a conditional. It's a condition that is going to allow the code to branch. Oh, if the sauce is kind of thick and I need to make it a little bit better and a little bit looser, then I can use a little bit of hot water, but only if the sauce is thick, not necessarily if the sauce is okay. So this is useful because now you can start creating a piece of software that can make all of these decisions based on these conditions. All right, so I'm going to share my screen, and we're going to be not exactly one-to-one, but we're going to be using this Microsoft Learn module called from the Take Your First Steps with Python learning path. And this one in particular is the branch code execution with the if and else statements in Python. Now, feel free to go through the module with me. Again, I'm not going to cover line by line. I tend to like kind of like tell you a story and try to figure it out how we can make these how can we make mistakes. Probably I'll try not to get into problems, but if I do, then that's good, because I think even seasoned experienced developers can make mistakes, and I make them all the time, and I have more than 10 years writing Python. So let's make it absolutely 100% real, and let's write some code live and see how that goes. All right, so we have the, hope you have the link to the learning path. I shared it in the comments. And now let's use, I'm going to open up, we're going to use two things. We're going to use VS Code, our text editor that we installed in the first episode. And I'm going to quickly change my program here. And this is what we had last time. We had our VS Code editor, and we wrote a hello.py, which is a script from Python that printed hello from VS Code. We briefly touched Jupyter notebooks, how to install them. We had them by default by installing the Python extension in VS Code. So we're to start tinkering, to start playing around with conditionals, we're going to use a new Jupyter notebook. So to do that, I'm going to go here, and I am going to go to the command palette. The command palette in Visual Studio Code has a oops. See, command palette has a you can it appears here in the view menu. So the command palette is kind of like your central place where you can type in anything that you may want, and it automatically, like, instead of learning all of the menus and the sub menus and all the options, like all of in your head, like you can just type whatever you think you want, and then the command palette will autocomplete and filter out everything out so that you can have exactly what you need. So in this case, I want the command palette I want to create a new Jupyter notebook. And look at this. Lo and behold, I haven't typed anything. I've just opened the command palette and it says, hey, create a new Jupyter notebook because I've recently used it. So I'm going to click that. And it's an untitled file, and it appears here as untitled-1, which is fine. If I wanted to save that file, it will say, hey, do you want to save it? And I can say yes. In fact, I want to save this as conditionals. Here we go, and I'm going to click save. There we go. Perfect. So we have now a Jupyter notebook. However, Jupyter notebooks need to be associated with a Python interpreter, right? So I have probably like 10 different versions of Python in different locations in my system. So what I need to do here is I need to select a kernel. If you didn't go through or the first episode where I talked about this, you can go back, check that one out, and then play around with it. If you're not sure what's going on here, this is just like an environment where I can type some Python, execute it, and see some results back. So I am going to click here on select kernel. I think it's an odd wording because really what I'm trying to select is just my Python interpreter. But the thing is that Jupyter notebooks have support for other languages as well, aside from Python. So I'm going to click here. And many different versions of Python are going to show up in my system, even Python 2.7, which is the default for the machine that I'm using today. I am going to use a temporary Python version, which is this one. I have it pre-installed. You can choose anything you may want. We're not going to install packages. If you install packages, you have to be very careful because you can get into trouble. And we'll cover that later in the series. But for today, it's fine. You can use any Python version that you may find in your in that list. If for whatever reason VS Code and Python doesn't show that up, you need to reload VS Code after installation of the Python extension. All right, so we have that. We've selected our kernel. Now we don't have a select your kernel prompt over here. It says Python 3.8. Don't worry if you have Python 3.9 or 3.10. I think it was like a week ago the Python release version 3.10. So it's fine. You can use that if you have it available. I would advise against using Python 2.7, but everything that we're going to do today should work for pretty much every version of Python that is available today. So conditionals, and we saw one Python statement last time, which was the print hello world. And so conditionals operate on, or they work on evaluating the thing that comes after the statement. So the statement, I know I said like three things there that are brand new. It might be a little bit confusing. So the statement, first statement here is going to be, let's say if. If is a statement. It's a key word in the Python language, and it allows us to start the branching statement. It's always said that Python sometimes can read like English, so it's one of the things that I like to do when I write Python. I want to write Python and get it as close as I can to English. So we're gonna take advantage of that a little bit. And I said two or three things. We start with a statement. In this case, is if, and that starts our branching out. And then we're going to evaluate a condition. Conditions are going to evaluate to true or false. That is the essence of conditionals in Python. So if a statement evaluates to true, then the next line will execute. It will branch off, and it will. If the sauce is thick, then yes, it's thick. Okay, like let's go to the next step. No, it's not thick. Oh, okay, let's skip that step and go somewhere else. So how about we use that same example from the story of the recipes? So we could say something here like if sauce is thick, right? We could do something like this, and we can say print use a cup of hot water. So there's a problem with this piece of code. We haven't defined what sauce is thick is. So we're gonna get into, I know I'm jumping a little bit around, but what we need to do here is we need to have that defined. This curly underscore for my variable that is in yellow, if I hover my mouse, my pointer, it will say, hey, this is not defined. Like, you need to define it. So no big problem. I can define it before. Python reads from the top to the bottom. So like in this case, we want to define sauce is thick. So let's just assume that sauce is thick. We're gonna use a value for that variable. So we're gonna write sauce is thick, and we're gonna say equals. So we're gonna have the name of the variable, the equals sign, and then we're gonna assign it a value. Now, Python has many different types of values that we can assign. And in this case, we are going to use a Boolean value. So the Boolean values in Python are true or false. And they are very particular, and they follow a strict syntax. So in other languages it's different. In Python, a true is capitalized. So the T is uppercase, and then RUE are lowercase. So it's a capitalized true. So we have sauce is thick equals true. And then we have our first conditional, which is if sauce is thick, print use a cup of hot water. So I can click this button over here that will allow us to execute this piece of code and see how it goes. And feel free to tinker around. Like if I'm writing these, like if you have VS Code in your system and you have your Jupyter notebook, you can definitely start typing this as I go and try it out. So I'm gonna click that, and of course use a cup of hot water. So my first condition was met, so this print statement got executed. So again, going back, the if statement evaluates if the condition is true or not. So in this case, sauce is thick is true, so print use a cup of water will execute. Now, what happens if we say sauce is thick equals false? Well, let's quickly change that and see what happens. So if we say false, and then we try to run this code again, then it runs and nothing prints. And nothing prints because if has to evaluate to true in order for this thing to print, for this next line to execute. Now, one thing that you may notice is that the print statement is indented. It's like it has like an indentation, and I've used the default in Python, which is 4 spaces. And that means that print statement belongs to that if clause. So the if statement comes in, and then the print, it belongs to that path. So it makes it much readable. Other languages are different, and they don't do it this way. In Python, Python statements and Python code, it's all organized by indentation, and I've used 4 spaces here. So that's fine. So things evaluate to true. So what if sometimes you may find code that, and I usually don't like to do this, but I'll show you a way to make this print statement execute even if sauce is thick is false. I don't like this because it kind of like makes you double check that what you're reading is in fact the right thing, because it uses a negation of what's going on here. So I'm going to use if not sauce is thick. Not is another Python statement. We just saw if, and now we can say not. Not basically changes to the opposite value of the statement. Sauce is thick is false, and now not sauce is thick will make it true. So if I hit the play button here, you will see that kind of confusing, right? I personally don't like to use it that way, and but in some occasions you might you might get into trouble if you do that. If you are trying to install the IPython kernel, that might take a while. I have it pre-installed here in this Python environment, so that's not a problem. It depends on your system and seeing if it can install the dependencies. All right, so we have our, like, I'm gonna remove these because I don't like the negation of a statement. But Python has another thing that we can use, and Python has an else statement. Now, when we were talking about our recipe, we said, oh, if the sauce is very thick, you can use some hot water to loosen it up. Otherwise, just continue with the recipe. So we can say else, and that comes here. So the else means anything else. So it's like only if that condition is met, only if the sauce is thick, do that. Otherwise, kind of like a blanket statement, like otherwise, it doesn't matter the universe, we're going to continue and do something else. And so the else statement will only execute if the sauce is not thick. So we can say here, we can add another print statement. So a lot of these help menus here. Yes, I want to use print. I'm going to say this sauce is okay. So if I run these, what do you think will happen? We remove the not condition. Sauce is thick equals false, so the sauce is not thick. So we can run and see what happens. The sauce is okay. So now that the sauce is not thick, sauce is thick equals false. So now we're seeing, oh, okay, so when certain conditions are met, I can do this, go down this path. Otherwise, I can go this other path over here. But what if you don't have like the water has to be hot? So we can say water is hot equals false. So now we can add an elif statement. We have if, we have else, and then there's an if else statement. The if else statement, I'll write it first as it is, and then I'll explain how is that similar to other ways of writing it in Python. So I'm going to say elif water is hot. No need to run some water. All good. All right. So we can run these, and then the sauce is still okay because the water is hot is false. So what's going on here? So the elif condition means it doesn't read like English too much, but it's short for else if. It's kind of like saying else, otherwise or except, like if this happens and this other thing happens, if this other condition. It's kind of like adding another chained else condition, like if it's not condition A, and try if condition B is this other thing, and then do these things. So elif does the same thing. This would be similar or basically the same if we wanted to say, if we wanted to add this thing. I'm gonna take it out and say else. We can say if water is hot. We can do that. So it's similar ways or different ways to like get the same result. And but now we start getting into the weeds on how branching works and how like we can take different decisions. So we have if, elif, and else. And we've talked a little bit about variables. And you can, the other thing that you can do is add more nested if statements. Now, be careful with nesting. That means adding another if conditions, because that will you will see code that starts getting indented, and you'll see kind of like a stairwell pattern where like a statement starts here and then gets indented and gets indented, and you can see code that sometimes the code goes like in angles, kind of like looking like a bracket, and that's not good, because then you start nesting statements, and then readability gets reduced, and it gets more problematic to figure out like what exactly is going on here. Alfredo is not a very good programmer. Like, I don't understand all of these ifs statements and these else, elif. Like, I'm getting confused. So it's okay. You can do it. You can tinker around with it, but try to keep it to a minimum. All right. So I'm gonna give you the example. I kind of like did the example already here. We could take this out from here and put it underneath the if sauce is thick, which would make more sense, right? Because if the water, we're only going to need we're going to need warm water if we need to loosen up the sauce, which is kind of good. All right. So if water is hot, you can say, no need to warm some water, all good. And you can also add an else statement here. Otherwise, like we can say else, we can say, need to warm some water for the sauce. Right? So let's run these and see what happens. I'll run these, and the sauce is still okay because the sauce is not thick. But let's change the values, right? Let's change the values here. True. Sauce is thick. Yeah, it's thick. We know it's thick. Somehow our code has figured out that it's thick. And now we have two statements being printed. Why? Because the first condition in the if statement is sauce is thick, so that evaluates to true. And the next, so he prints out use a cup of hot water, and then evaluates the next one. If water is hot, right? If water is hot, so is it hot or not? It's not hot, so it doesn't say no need to warm water. It's just all good. It says, hey, you need to warm some water for the sauce. So that's what we get. That's why we get two statements. So this is what allows us to kind of like get a little bit of branching statements and seeing some variables, how a variable can affect a program. Like, this is effectively a program in Python. You're writing some Python, you're using some conditionals, you are the learning path uses branch code execution, but that's just a fancy way of saying, hey, I can take decisions. My code can decide if it goes over there or goes over here, if it uses hot water or if it doesn't use hot water. If you want to create a dynamic recipe, like imagine if this was an application that could dynamically say, hey, like you don't have these, your sauce is thick, we have some sensor in the sauce, and so your code could actually start doing that. So that's pretty exciting, because our code can start now to make some cool decisions and make some things happen. Okay, so we have our Jupyter notebook. We've covered a little bit of these things, but beyond these, there are a couple of things that are interesting and good to know, that if you don't know them, you might get into trouble. So and I'm going to create another, this is pretty useful. I'm going to create another cell over here. I'm going to scroll down. So I'm going to leave that there. All right. So I mentioned that an if and else, well, else no, but if and elif statements evaluate if a condition is true or false. Sometimes, like these, I made it kind of like easy and straightforward by defining sauce is thick equals true and water is hot equals false. So directly saying, hey, this is false and this is true. But Python has many types of variables, right? So you can say, for example, a variable might be a string, or a variable might be a number. So what happens in those situations? Well, you might assume that certain things are evaluated true and some other things not evaluate to false. So we'll see a little bit of those examples here, and those are also in the Microsoft Learn module that you should be following. Some of those examples are there. I'll touch on a few so that you are just aware. And then I know I'm not supposed to like touch on data structures yet, but we'll use it just a little bit so that we can see the surprising side effects of using them as conditions. So we can say, for example, what happens if we have a username and the username is an empty string. We have a username that is blank. There's nothing in there. So if we say if username, you could actually say that. You could use the variable just as before. We can say we have a username. And then we're going to say else, no username. I'm going to type that. So now we've defined username as an empty string. Let's run it very quickly, see what happens. No username. Why? Because an empty string evaluates to false. How do we know that? We are going to say, we're going to put here, there's a built-in function. I know we have not covered functions yet, but there's this nifty utility that you can use to kind of like check if something evaluates to true or false. So we can say bool. Bool is a built-in function, and we can say username. We're going to pass in the value of username. Just like print is a function, bool is a function as well. So bool will, and I don't think, let's see if it prints. I don't think it will print. It printed false. So that means that the Python is looking at username and says like, oh, this is a false, evaluates to false. That's what bool does. Like it looks at the value of a variable, and if it evaluates to false, then it says, this is false. So what if we have something else here? What if we say, if we say Alfredo, we're going to click play, and now it's evaluates true. So a string that has some contents in it will evaluate to true. A string that is empty will evaluate to false. What happens if it has a white space in there? What do you think will happen? Will that evaluate to true or to false? It evaluates to true. I click play. I think that wasn't that wasn't a thing, but it didn't show like correctly that I was clicking on the play button. But like an empty string, you say, well, this string is empty. Well, it's not technically empty because there's white space in it. So now we're getting into the surprising facts of variables, right? Then what are things? Well, we have ones and zeros and integers, so we could say one. I know, like username one is kind of like odd, but let's see what happens. So if I click play, oh, we have a username. What do you think happens if I put a zero? A zero evaluates to false in Python. So no username, and bool username, it becomes false. There are many other types of values that we can assign to Python variables. I know we haven't covered none, but none is valid, like if the username is valid, but a none evaluates to false as well. Now, and this is where I wanted to show you this a little bit, because it can it can catch you off guard if you're already into data structures and doing stuff with Python. I'm going to use just one data structure. It's very simple or very straightforward to use, which is Python lists. Lists are like a container. You can put stuff in there. We're going to see data structures in other episodes, but just for this example, let me quickly, like if you're not familiar with lists or data structures, um, don't get overwhelmed. Like I'm just going to briefly use it and use like an empty list and then a list with an item and see what's the difference. So let's say, for example, you're writing a system that deals with usernames. So I'm going to change to usernames because a list is a container of things. And because it can have many things, I want to use usernames, the plural. So now it reads better. All right. So I'm going to use the definition for. I'm going to create an empty list. An empty list is with square brackets. So square bracket, beginning and ending, and that's how you define an empty list. So Python, I'm going to click play now. Python evaluates an empty list to false. So if you're saying, hey, if I have usernames, this thing, oh, you don't have anything, your data structure is empty. And this is the same for every single data structure in Python. If the data structure is empty, it will evaluate to false. So if we say, I want to put Alfredo over here. Yes, we have one username, which is Alfredo, and when I click play, ooh, we have a username. When in reality, we have at least one, right? And now it evaluates to true. So this is kind of neat because now we are understanding that certain things, certain variable values can have certain consequences. They might be evaluated to true or to false, and we have to be aware of them to make proper decisions. So I'm going to shift here a little bit and spend a few minutes creating a Python program that will ask me a question, and then we'll act on that. It's kind of like I've extracted from a real world, real scenario piece of code, and I'm gonna use that. We're gonna write that from scratch and see how that goes. And we're gonna use a different built-in function called input. Once we call input, it will prompt us to type something on the terminal. So I'm going to use my terminal, and then we're gonna write this program. But we can still use VS Code. I'm just going to use the terminal to run it. Oh, actually, VS Code can also run it, so we can actually stay in VS Code all the time. So I've built this file called str to bool, basically meaning string to Boolean. So I'm going to click that. Takes us to a different tab in VS Code, and we have several things. Now, initially, I had typed this with using lists. We're not covering lists yet, so I'm going to, in essence, I'm gonna modify these live so we can have like a similar effect. So what we're gonna do is we're gonna prompt the user to type a yes or no answer, and we're gonna evaluate that if it's kind of like, oh, this person is actually saying yes, or this person is actually saying something like no. And we're gonna have several different options that are going to like synonyms of or similar to yes or true and no or false. Okay, so that's the basic idea. And we are going to say response. We're going to create a variable name, and we're going to say input. Let's see. Are you hungry today? Are you hungry right now? So it's a pretty simple question. So that's like a yes or no question. I'm going to comment this out. Or how about we're gonna remove these because I just left it there as a reference. So are you hungry right now? So what happens if I think this is to run it. So if I click that, it tells me, are you hungry right now? That's this right below. It's my terminal. And I can say, yes. So it allows me to type and then to hit return or enter. And then that's it. The program exits. So just this response, it captures my input. So what we can do here is say, print response from user was comma response. Let's try that. I'm gonna run it again, and I'm gonna say yes. I'm gonna go back down to the terminal. I'm gonna say yes, and response from user was yes. Okay, so what is it that we're doing? We're prompting the user for input. We're asking a question. I'm typing it like as a user, typing it in the terminal, and then hitting return, and then that gets captured by the program, and the program says, oh, okay, so the user said these things. So we're able to assign that input from the user to a variable and then use that inside Python. That's really neat and useful, and allows us to interact with a user if we ever have to. So what about the conditionals, Alfredo? Like this is pretty good, but what does it have to do with conditionals? Well, we can go and try to make it a conditional so that we allow the user to say yes or no or 1 or 0, and then kind of like take action on that. So we're gonna say if response is yes. So we're gonna use an operator. The operator that we're gonna use is double equals. That means if the response is this thing, so in this case, we're gonna say yes. We're gonna say user agrees that there is hunger at the moment. That's very odd way to say it, but whatever. So the double, we haven't used the double equal sign, but we're saying if the response is yes, what do you think would happen if I used a single equal sign? Well, that's not comparing. It's no longer an operator. I'm trying to assign it. So it's a syntax error. Python says, oh, you can't do that. You're using an if statement. So it has to be a clause. It has to evaluate either to true or to false. So if I'm going to do that, if the response is yes, that double equals means basically yes, then we're hungry. Otherwise, we can say, for example, else if or elif response is no, there we go, print user is not hungry at the moment, and then we can try that. So we're gonna run these again. Are you hungry right now? I'm gonna say, how about I say no in lowercase, and I do that. Response from the user was no, so I didn't catch that condition because we are only checking if the response is yes capitalized or no capitalized. So how do we make these capture this condition? Well, we need to add another elif or else if condition here to capture that. But you can see now that there's a couple of ways that we can do these. We can say if response equals, we said no, right? So we can say here, we could say elif response is no in lowercase, and then basically copy the same response and say it like that. So we could do that, and if we do that, and if we run it, and we type no, then user is not hungry at the moment. But we're repeating the lines, we're repeating the code, and that starts to get complicated and reduces readability, creates a little bit of confusion, because if I'm I'm a developer and I'm looking at these, I'm saying, well, why is this repeated? Because now if I need to make a change, then I need to make a change in every single spot where this was repeated. So let's make it a little bit better. So instead of saying elif response no, we can use or. We can say or response is no. So we can say something like that, and then we can remove these. You can remove these two lines. Sorry, that's scrolling out of there. And we can make the terminal a little bit smaller. There we go. So we can say elif response no or response lowercase no, then that will work. So let me save that, run it again with this button. So I can say no, and then the user is not hungry at the moment. So with input and asking a question, capturing that response from the user, then we start seeing that there's potential there for capturing that information, using it within Python, and then trying to do something else. Now, let's do something very, very nifty here, because we have the yes and no. But what if we want to kind of like generalize this a little bit? So we could use the Boolean function, the bool function from before, and try to see if we can make it general. It's like, oh, like whatever other input that this person added, like let's try and evaluate that. So we can say else. We can say not else. We can say elif bool and say response. So that means, remember, like what the values that we use in the conditionals here, right? Conditionals. We said, well, we're not gonna pass an empty data structure, but like we use the numbers, we use an empty string. So if we say elif bool response, we can say print. The user is probably hungry, and then we can finally say else. Can process that response. We don't know what to do, right? So when I click save, I click this to run the program. All right, are you hungry right now? What about I put an empty string? Oops, no, I don't want this. I pressed a different button. The user is probably hungry. Response from the user was like, and we can't really see what's there because I passed an empty string. I pressed the space bar several times and then hit return. So we started, we hit this condition because I didn't type in yes, as in line 6. I didn't type in no, either capitalize or underscore. And then we got to line 10 and the evaluation to response, because remember, a string that has white space, it evaluates to true. So the user is probably hungry. Like he can't type. He's typing. He's typing something. He's so hungry that he's typing some things in the terminal that is going to cause a problem. So now let's make these hit that last line. Couldn't process the response. So what if we hit play again, and then I'm just going to hit return. No space bar, no nothing. So couldn't process that response. So perfect. So now we're selecting what we want. We're evaluating to true or false. We're making some decisions based on that input. And at the end, well, if we don't really recognize that, we can say, I couldn't process that response and can't really enter what's going on there. All right. So we've covered the module pretty well, I think. I think we still have a few minutes for some questions. So if you have some questions, please go ahead, ask me anything. It can be about this specifically that we just went through today, or perhaps you have like generic Python doubts on how to make this better or how to improve it, or if you have some doubts on anything related to Python or the series that we're doing today, please ask away. Happy to answer any other questions that you may have. Like I said, we've been doing this series. We're doing them every Wednesday. Oh yeah, we have. Well, this is not exactly a question, but like kind of like a comment. Can we use that lower? And yes, we can definitely use that lower. Could you please show the code for the bool response function one more? Yes, it's we can this is that's the code for the Boolean response. There we go. So so the statement or the comment was, can we use that lower? So what is that lower? That lower is a thing that allows us to operate or a method for a string. So we could say in this line, in line number 8, instead of like doing uppercase capitalized no or underscore no, we could certainly use that lower, and I'm going to show you how. Now this might be a little bit more advanced because it starts using the string method. So we could say that lower and is no, then it doesn't matter how I type it. I'm going to show you. That's an excellent comment. I try to avoid getting into other things that we can do because I don't want to make it super overwhelming for someone that is just starting to see strings and other types. So we can say that. So how about we do a condition that we haven't defined? It doesn't appear anywhere in the code. We're going to say no, all uppercase. What do you think it will happen? User is not hungry at the moment, so we are hitting this condition right there. So if you find yourself like using that lower all over the place, you could also say you could also put it here, for example. Oops. You could also do it there. That way you don't have to check anything. So we can try that. I'm going to say yes. And the user is probably hungry. Now we're hitting, now response doesn't need to be lowercase. So it's just like different ways of doing it. If you feel overwhelmed by this little thing that I changed here, don't be. Different data types in Python have different methods that can affect how we represent the value on it. So using that lower is a way of like always ensuring that the value of that string is lowercase and making it easier to make these types of if, else, elif conditionals. Let's see. We have another question from Carlos Fuentes. Would the bool response only be called if the user input 0, 1, or true or false? Yes, we can certainly do that. We would probably need to find. I didn't tell you these to try to keep things simple, but anything that comes through the input function will come as a string. So if I type in a 1 or a 0, it doesn't come as an integer. In Python, an integer is, it's a specific, it's not a string. An integer is a number. It has its own properties. So if we wanted to capture input 0 or 1 and treat it as an integer, well, we would need to kind of like massage the input a little bit and try to make it work. You can certainly do that as well. But the other alternative is to use these possible inputs in a data structure. So when we started, I had a list. So we could say, for example, false values are no, and we can say 0, right? A string 0, and we can say, for example, n. And then we, instead of response lower equals no, we can say response lower in false values. So now we can have all those options there, and we can say, for example, yeah, I hit N, and user is not hungry at the moment, and then it works. All right. Well, if you guys don't have any other questions, it was great to talk to you about conditionals and variables. And the next series is all about data structures. I mean, I briefly hinted a little bit on data structures today, but that's coming up, and we'll do all kinds of other interesting things with data structures. Definitely the next step is data structures, and it will make you a much better Python developer, and we'll catch some tricks and surprising things with data structures, just kind of like what we did today with those Boolean expressions that can be kind of tricky.
Exactly. Thank you so much, Alfredo. This is great. And thank you to our audience for tuning in and sticking around. As he mentioned, so we, same time, same place, on October 20th, we'll be going on to the next one of this series. Again, if you missed the first session, do feel free to check out the recording. It is live on YouTube right now. I shared in the link the event calendar for the series page, and the video is there. You can also find us on Microsoft Reactor YouTube channel. And then if you are able to do so, a little brief plug, like I dropped in the chat, a link to our survey. We are always trying to get the audience feedback for future development on content. We are constantly putting out new stuff. So whether you're joining us from wherever in the world, there is an event for you and a time for you. So definitely check out that survey, let us know. And then, yeah, join our community if you haven't done so already. So we are on Meetup. We have 11 physical spaces. So those locations are available on Meetup. Just search for Microsoft Reactor, find the one in your region closest to you to see the most relevant content that we're putting out. But we also have a website, microsoftreactor.com. And let's say you work late or you are up early, maybe one of the other regions has some events that aren't listed on your local calendar. So definitely check out time and everything that works for you. All right, at this time, I think we'll call it. Thank you all. Bye now.